Okay, good morning. Today we want to talk about the next part of the lesson, which is amplitude and period of trigonometric functions. So we learned how to, we get familiar to actually the graph of sine and cosine functions. Now we want to actually study a little bit more because the ones that we study are just sine and cosine, if you remember, yes? Okay? So we want to do two things in two lessons. Okay, one lesson is that what happens if I multiply my sine and cosine function by a number, and what happens if I multiply the x by a number, how this will affect the graph of the function. So for example, let us concentrate, because whatever I'm going to say about this, it also works for cosine, it doesn't matter. For example, my question is, if I give you the graph of this function, how can you understand the graph of this function, for example? That's the same function, just multiplied by a factor of 2, okay? And I want to ask the same question for this. What happens if I take and multiply the x by 3, for example? Or I can have a combination of them. For example, I can write y equals to 2 sine 3x. So that is actually the lesson for today. I can also do the same things for cosine, but the rules are the same. So the question is that, by the way, in your book it is talking about sine and cosine functions, but the rules that I am trying to say here are completely generic, so it doesn't matter. If I give you the graph of any function, assume that you don't have access to the formula for the function, but you have access to the graph of the function. And I say that, okay, by looking at the graph of the function of f, can you say something about the graph of the function, say, 2 times f of x? Yes, this is one question. Can you say something about the graph of f of 3x? So the book has decided to talk only about trigonometric functions, but the rules that I am saying here is more or less this, not exactly the same for these, actually. For example, if I give you a function, y equals to, for example, a square root of x, okay? For example, you shouldn't, probably you don't know the graph of this function, but this would be something like this. The graph of this function is of this behavior, okay? Y equals to the square root of x. Of course, at 0 it is 0, at 1 it is 1. I have to be a little bit more careful because at 4 it is 2, yes? 1, 2, 3, 4, something like this. Yeah, I have to be a little bit higher here. So anyway, but forget about so assume that you don't know the rule, but this graph is given to you, and they are telling you that this graph represents a function, okay? That function. Now they ask you, if you multiply that function by 2, how will be the graph of the new function? This function is a different function. They might ask you, what is the graph of this function? So you see, I hope that you feel the difference. Here I decided to multiply the whole function by a number. Here I decided to multiply only x by a number, which is not the same as before. So they might ask you the graph of these questions. So your book has decided to only talk about trigonometric functions, which of course is a little bit easier to understand. Okay, is the question clear? So the graph of this we already know. We want to answer, how is the graph of this one, how is the graph of this? I want you to understand the behavior because I can draw them with GeoGebra even nicer. Okay, we will do that, but I want you to understand. Okay, so let us try to understand that. In order to do that, if you don't mind, let me start with my table again, and you will realize what will happen. Okay, so the famous angles that I used for drawing the graph of sine were 0 degrees, 90 degrees, 180 degrees, and 270 degrees, and finally 360 degrees. I use only these to give you a flavor of the graph of sine function. I will do the same thing here today as well. So let me just repeat sine x. For sine x, it was 0, 1, 0, minus 1, 0. Now, let us try to understand by the way, let me just draw the graph here on the board so that we can compare them, okay? I want you to understand the behavior of the new graph. Okay, so let me just, I want to just draw it in one period, okay? So here, assume that here is 0 degrees, assume that here is 90 degrees, make it a little bit bigger, 90. And then this one is 180. And then this one is 270. And then finally this one is 360. Yes? And then of course here I have 0. And then here assume that this is 1 and the same value here is negative 1. And then I have it here. And then I have it here. And then I have it here. I'm just drawing the sine function as just we did before. And this is the graph of sine function. Yes, we had this before in one period, of course. But now let me add another row to this table. And that is, for example, this function. I'm just picking up 2. You can multiply it by any number that you like. Okay, what will happen? Instead of having this row, I will concentrate on the values of this function. Again, I put 0 for x, sine of 0 degrees is 0. I multiply it by 2, but still I get the same value. Yes? But when I put 90 degrees, sine of 90 degrees is 1. But I multiply it by 2. So what will happen? I hope that you see what is going to happen. What will happen? All the y values that you had now becomes 2 times larger. So 0 still becomes 0 because 2 times 0 is 0. 1 becomes 2. What happens here? 0. What happens here? Minus 2. And again 0. Now let us try to understand what is happening here. So if it is 0 degrees, it is 0. So it's still the same point. But what is happening? Every y value is now doubled in size. Yes? Of course, I haven't drawn all the points, but you can understand that whatever I had here, what value I had here, this value will be also doubled. So it means the y values are doubled. Okay? Okay, so it means that, for example, when I am at 90, I will not end up with the height 1, I will end up with height 2, which is here. That would be, but this will not change because the height is 0. If I double it, still the height is 0. Here the height is negative 1, so it goes to negative 2. Yes? And then this is the 0. So if I draw this graph, then you understand what is going on. Oops, it's not a good shape. Yeah, it's hard to draw this on the board, but we will do it in GeoGebra later. Okay, so somehow better. Okay? So how can you describe this behavior? What is happening? Assume that this curve is a rubber band. So what you have done, you have stretched it along the y direction without affecting the anything on the x direction, yes? Because you see the nodes are still the same. So I haven't done anything to the graph along the x direction. What I have done, I have stretched the graph 2 times larger on the y direction. Yes? So that's the idea. So if you multiply your function by a number, the effect will be what? Something along the y direction. Okay? If you multiply it by 2, you are stretching it 2 times larger. But you can also squeeze it. Can you imagine, for example, can you tell me a function that is exactly the same as the black curve, but it is the squeezed version of the black curve. So what type of number I have to multiply? So you see that if I multiply it by 2, I had that one. What happens if I multiply by 3? Yeah, it becomes 3 times larger. But now I want to squeeze it. So I multiply it by, for example, 1/2. What happens if I multiply it by 1/2 and have this function, and I have 1/2 sine x, then this becomes, so I have to compare it with these two rows. Be careful. I multiply this by 1/2, I multiply this by 1/2, I multiply this by 1/2, 1/2 and 1/2. And then what I get another curve. So here, if it is 90 degrees, it is 1/2. So that is the point, 0.5. And again, this point is the same, this point is here, this point is the same. Instead of having minus 2 or minus 1, I will have minus 0.5, which will be here, yes? And then finally this one. So I will get this green curve. Yes? So it seems that this is the same black curve unless it is squeezed, yes, by a factor of 2. So it is now, the rule is clear. So if you multiply by 1, of course nothing has changed. If you multiply by a number which is greater than 1, you are stretching it, but remember, along which direction? Y direction. If you multiply it by a number between 0 and 1, you are squeezing it again along the Y direction. Of course, in the book they haven't talked about multiplying by a negative number. But that is also understandable. So what do you think it will happen? If I multiply sine, instead of multiplying by 2, I just multiply it by minus 2. What will happen?
Mirror the black line.
Yeah, so it means that, because if I multiply by minus 2, this will be the same, but this becomes minus 2, this becomes 0, this becomes positive 2, and that becomes 0. That will be the mirror image of this blue curve about the x-axis. So it doesn't matter, even if you multiply by a negative sign, you can understand it. Yes? So you draw with the positive sign, and in your head you flip it about the x-axis. Yes? So multiplying by a negative sign is also not a problem. Okay, but this terminology I want you to understand, probably you also have seen this in physics if you have studied waves, okay? So this amplitude means, if you consider it from physics point of view, assume that this is a piece of rope or string, and then you are making this wave, okay? The amplitude means the highest deviation from the equilibrium position, okay? So assume that this was your string before, this is the equilibrium position. The highest, the maximum deviation from the equilibrium is called the amplitude. And by definition, amplitude is positive. So what is the highest deviation for the black curve? 1. So don't say minus 1. By definition, amplitude is always positive, the maximum deviation. So what is the amplitude of the blue curve? 2, and the amplitude of the green one is 1/2. So that's called the amplitude, okay? So don't say maximum and minimum. Here, the amplitude coincides with maximum and minimum, yes? But might be I have this scenario, might be we'll see later. For example, if I have this function, so assume that I have this function, okay? We will see, for example. But the maximum is still a negative number. Don't say that the maximum is the amplitude, because amplitude by definition is positive one. So what is the amplitude? Exactly. You need to find the line of equilibrium and then say that, okay, the amplitude is this deviation. How much is that? You need to understand it from the, but don't say that this is the amplitude. So the amplitude is the maximum deviation from the equilibrium position. Okay, so that's called the amplitude, which in this case coincides with maximum, but in this case it does not coincide with the maximum value, because the maximum values are still negative, you see, but that is not, yes?
What do you call it if you want to find out the negative peak between the equilibrium and the waves that go like below?
So if you want to find, that's also a good question. So what you can do, if you want to find the equilibrium position, so what you have, we will answer that in the next lesson actually. So how do you find the equilibrium position? It is the average between minimum and maximum. So you find, for example, if this is -2 and this is -4, if you want to find the position of the equilibrium line, what you do, you need to add these two and then divide it by 2. -2 plus -4 and then divided by 2, which is -3. Yes? That will give you the line of equilibrium. Yes, so that is clear, yes, because -3 is here. Yeah? Yeah, we will come to this in the next lesson. That would be better, because here it is not hard. All the graphs are as before, so reading the amplitude is very simple. Reading the equilibrium line is very simple, but that would be the topic of the next lesson. Any questions here? Okay, so this is one thing we learned. If I multiply my function, the whole function, by a number, the effect will be stretching or squeezing along the y direction. But now the interesting question is that what happens if I multiply it by a number? So if you don't mind, multiplying by 3 will be a little bit harder. So let me still multiply by 2. But then you will see something interesting happens. So let me clean this board. We don't need it anymore. Now, let me again. Oh, I shouldn't have cleaned the first. Okay, I will clean this one. Not one. So here I want to talk about 2x because that is better. Yes. Here I multiply 2 outside. Now I decide to multiply 2 inside. Let us see what will happen now. Okay, so this might be a little bit confusing. So, but I want you to understand this. So I will take sine 2x here. But the values that I choose, I will choose 0 and 45 and then 190 degrees. You will see why. And then 135 degrees and then 180 degrees. Okay? Of course, in the previous case, I also need to consider all values. The reason that I didn't consider them, because first of all, I didn't have it in my memory, and then drawing that would be hard. But in principle, you need to understand, you have to consider all range of values for both cases. But the reason that I picked these numbers has there is some reason for that, and you will understand. Okay, so let us calculate this. You put 0 instead of x. Then you multiply it by 2 is still 0, and then take sine again 0. And now, you remember, when I wanted to reach to this peak for the black curve, I have to wait until I reach to 90. Yes? When I reach to 90, I will reach to this highest value. But because of this factor of 2, I achieved the maximum earlier. Yes? Because when I pick 45, when I put it here, because there is a factor of 2, this 45 will be multiplied by 2, and it will give me 90, and sine of 90 is 1. So you see, in the previous case, if I want to reach to this height, I have to wait until I reach to 90. But in the new case, I will achieve the maximum height when I am at 45. Because of this factor of 2, I will speed up. Yes, is that understandable? Okay, and then when I reach to 90, what happens? I put 90 here. 2 times 90 is 180, but sine of 180 is 0. So you see, this is also, if I wanted to reach to 0, I have to wait until I reach to 180. But now I reach to that 0 faster. I reach to that 0 when I am at 90. And then when I go 135, I multiply it by 2. It becomes 270. Sine of 270 is -1. And again, you see, in the previous cases, when I wanted to reach the minimum value, I have to wait until I reach to 270. But it has accelerated here, yes? I reach to the same negative value minus 1 when I am at 135. And then, of course, when I put 180 here, it becomes 0 again. Okay, let me just draw the graph of this one now. 0, 0, and then 45, 1. So 45 is in the middle, and then 1. So this is my point now. And then 90, 0. Oh, sorry. Okay, so 90, 0 is here, and then 135 minus 1. 135 is here. Minus 1. And then finally, 180, 0. It's here. Okay, so what's happening now? If I draw this red curve, I will get this. So what is happening, do you think? Compare it with the original graph, because what do we have? We have the graph of sine, which is the black curve. Everything you need to compare it with the original one that you have in your memory, yes?
I would say it's compressed.
It's compressed or squeezed, yes?
Yeah.
But along the x direction this time. So it is counterintuitive. You are multiplying by 2. Might be you expect that still it is being stretched, but it is not. It is being squeezed. Okay? So the effects are different. This is more natural for intuition, our intuition, yes? It's a little bit more counterintuitive here. Here you multiplied by 2, the effect was stretching it along the y direction 2 times larger, but here you are multiplying the angle by 2, but the effect, first of all, is not on the y direction. Look, nothing has changed in the y direction. The height in the black one is 1, the minimum value is minus 1, still they are the same. So nothing has happened on the y direction, but I have squeezed the graph of the black one 2 times larger. So, okay, I made it half size of the previous. Okay, now let me ask you one question. What was the period of the black curve? So the period of the black curve, because you need to copy and paste this part. Yes, so this is from 0 to 360 degrees. But what is the period of the new function? It's just 180 degrees. What is the amplitude of the black curve? 1. What is the amplitude of the new red curve? 1. It's still 1. So you see, multiplying the function will affect the amplitude, but not the period. Multiplying the angle affects the period, but not the amplitude. Yes, is that clear? Okay, so that is the idea that I want you to learn. For example, can you squeeze along the x direction? Sorry, that was a squeezing. Can you stretch along the x direction? How? Yes? Matthias, yeah. 0.5, for example. Yes? You multiply it by 0.5, okay? And then you will see the effect will be stretching it. Okay. So now, one thing that I want you to learn is that, so the period here, the period of the original function was 360 degrees. For this new function, it became 180 degrees. So you divide it by 2. In general, if you have this function, this is something you will be given in the formula sheet, but I want you to understand it as well. So if you have these two functions, and if a is positive, the amplitude of both of them are 1. But the period of both of them is actually this divided by b. I just gave you one example here. When I had 2, the period was 180 rather than 360 degrees. So I have divided by 2. But now if this is in total B, that would be this is also given in the formula sheet, and this is expressed in degrees. Sometimes they ask you to express in radians, and this is another formula in radians. Yes?
What did T stand for?
T is period, sorry. In physics is also T period. Capital P is called the period. This is the symbol for period. So the period of these two functions follow the same rules in degrees, in radians, and the amplitudes are A if A is positive. Yes, is that clear? So this is today's lesson actually. But there are some good questions in the book that we want to discuss about them. Okay, so let us come here. This is the example in the book. So this is important for me that you understand this. So if you have this graph, so what is the maximum and minimum of this graph? This is something I want you to learn. Don't ask me this question. So for example, here this is given to be 1. Okay? This is given only that to understand how much is each one of these grids. Okay? So when here is 1, then you have 1 grid here, 2, 3, and 4. So this is important to understand. The length of each grid is 1 over 4 or 0.25. So when I ask you what is the amplitude, amplitude is the maximum deviation from the equilibrium. Hopefully you agree that this is the amplitude, yes? How many grids you see there? 2. Each grid was 0.25, so you double it, it becomes 0.5, so this is the value of the maximum. Okay? But I have seen some students make this mistake when I ask about the period. Of course, this is correct. The period is from here, I agree with you, up to here, yes? Because if you take this part of the graph, yes, and copy and paste it over and over again, definitely you will generate this one. But you cannot see that, you cannot say that by my eyes, this is in the middle. Yes? So you have to understand that you need to go and look for the points that are really passing through these grid points. Yes? Is that understandable? Because that is how it is. So you cannot say that I guess that this is in the middle. So because if you can guess, then it is easy. You would say I go from here to here. Yes? This is one. By the way, what are the grids on the x-axis direction? How much are they? This is again the same story. So here is pi over 2. How many of them you have? 1 grid, 2, 3, 4, 5, 6. So how much is each grid? The whole length here you see the whole length is pi over 2, but it contains 6 of those grids. Yes? So each grid is how much? Pi over 2 divided by 6. So which is pi over 12. So each grid is pi over 12. Okay? And now you say that, okay, this is 1 grid, complete grid, 2 complete, 3 complete, 4 complete. Yes? So I have 4 complete grids, and then you might say that, okay, I can check that this is half a grid, and that's also half a grid. It becomes 1 grid. Yes? This is not acceptable. Of course, most of the questions I will require the final answer. So how you can convince you, that is up to you. Okay? But this is not the standard way to do it. Okay, so in that case, what you need to do, you need to consider this point, for example, and that point, which are passing through the grids exactly. Yes, and then you can see 1, 2, 3, 4, and 5. Am I right? 1, 2, 3, 4, and 5. So what I'm trying to tell, even though from here to here is also the period, I agree with that, but I have to do it from here to here because I have this information given me on the figure. Yes. So what is the period here? 1, 2, 3, 4, 5. Yes. And then you need to multiply this by 5.
5 pi over 12.
Yeah, so it is 5 pi over 12. Yes. So am I right? But I don't know what they have written here. 2 pi contains 5 periods. Yes. That's right. But the period is this much. 5 pi over 12. So that's the way that you read it from the graph. Is that understandable? Yes? Okay. Let us see some of the examples in the book are actually good examples. Let us see. Yeah, here. Yeah, let us answer some of these questions. It is good. Let us do them together. Okay, so let us answer this very simple question. What are the amplitudes of these two graphs? Yeah, just tell me. For example, the red graph. What is the amplitude of the red graph? Just say it. 3. And what is the amplitude of the blue graph? 1/2. So that's the amplitude. That's very simple. Okay, can you tell me just what are the periods? What is the period of the blue curve? No. No, by the way, this is a common mistake sometimes. 180 is not the period. Why? Now, first of all, okay, even if you know, let me explain this. Why this is not a period? Because if I take this part and copy and paste it, I will not get the same curve. You see, I have something extra here if I copy and paste that part. Okay, so that is not one complete period, because by copy and pasting only that part, you get something which is not this red curve. Okay, but the period, is this a period or not? This is a period, because if you take this part and copy and paste it over and over again, you will generate a red curve. Okay, and then from here to here is your period, which is 360 degrees. Now let us answer the same thing for the blue curve. So can I say from here, so what is the period here? So from here to here is not still a period, yes? I have to continue up to here to have the period. So from here to here is one period. Is that understandable? So then I need to find the length from minus 180 up to 540, which is 720. So the period of the blue curve is 720. So this is something that you need to learn how to use the graph to understand that. Okay, so let us answer this question now. What is the maximum and minimum values of these functions? Okay, so for example, let us consider part A. What is the maximum of y? 3. And what's the minimum? -3, yes? Because the maximum value of sine is maximally 1, minimally -1. You multiply it by 3, so it becomes between -3 and 3. Okay, what about this one? What is the maximum value of y?
1/2.
1/2, yes? It is 3 over 2, yes? Understandable?
Yes.
Okay. So what is the amplitude of this function? What is the amplitude? Only x is being multiplied by a number, so it will not affect the y direction. So the amplitude is still 1. Okay. Okay, can you, for example, answer this question here? And these are simple questions, yes? What we have to do, okay, so what I want you to tell me is this. Let me just explain it. So we have two curves on this graph. This is telling you that the blue curve is this red curve has this rule. So this is the rule for the red curve. And it is telling you that the function for the blue curve is of this form. Using the information given on the picture, you are supposed to find the exact value for A and the exact value for B. By the way, these sort of questions you will get in the exam. I will not give questions to draw the graph. I want you to understand how the graph actually behaves. So that's the question. I think I would pause recording and I want you to think about this problem, okay? Is the question clear? So the function for the blue curve is given to you exactly, and they are also giving the red curve, and they have given you the information about the blue curve, but of course A and B are missing. You are supposed to find A and B. Yeah, if you can solve that problem, it means that you understood everything for today's lesson. This question is interesting because you do not see any numbers on the x-axis. That is actually the point of this question. You see something on the y-axis, so you can understand the grids, but you don't see any number. You cannot pre-assume that this is probably this number, they have missed it to give it to us. No, you have to find those grids. Okay, one question. So from these two numbers, one is extremely simple. Even under 1 second, you should be able to find that. Which one is that? A. Yes? Because I told you that A means the amplitude. And then you don't need anything. You can immediately see the amplitude of the blue curve. What is the amplitude of the blue curve according to the information given? 1. So A is 1. Understandable for everyone or not? Because this number, I told you that what is the role of this A? It will change the amplitude. Yes, but by just looking at that, because that information is given to me, this height, whatever it is, the deviation from the equilibrium is 1 unit. So this means that A is definitely equal to 1. So the hard part is to find this B. Okay, and you know that B is somehow related to the information on the x-axis, which is missing apparently. But this is given to you in a direct way, in an indirect way, by giving you the equation for the red curve. Okay, so can you give me a strategy? Because I want to do it on the board, I have to switch back and forth. Yes?
Put y to be 0, because it's where the red one is going to touch the x-axis.
Yeah, that is a good idea. By the way, I didn't think about that way. This is a good idea, but it is harder than the one that I want to mention. Yes, you are right. If you put this equal to 0, so what Abdullah is saying is that you take this one and put it equal to 0. When you put this function equal to 0, what do you get? You get the zeros of that function. Okay? For example, the first 0 of that function, of the red function, appears here. You solve that equation, you find it, and then you say that, okay, this is that number. Then you divide it by 1, 2, 3, 4, 5, 6, and you get the length of each grid, for example. This is possible. But let us work with periods and things like that, okay? That is my goal to do it here. So if I give you this function here, what is the period of this function? Don't look at the graph, use the formula. So let me go to the board. So what is my function? My function is y equals to 1/3 cosine of 2x. So this is my function. If I ask you what is the period of this function, you have the formula in the formula sheet. Here is on the board, yes? So t is equal to, I don't know if you want to work in radians or degrees. It is not mentioned here, so let us work with radians, okay? So I would write 2 pi over 2. So this is pi. So I understand that the period of the red curve is pi. This is the total period, okay? So let us go back now to the picture. So from where to where is one period for the red curve? From here, yes, to here, yes? From this point to that point is one period for the red curve. Yes, understandable? Okay. This length from here to here is supposed to be equal to what we found, which is pi. Yes? Okay. Then you need to calculate how many grids are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and of course how many more? 12 more, so 24. So it means that this period divided by 24 will be the length of each one of those grids. Yes? So that is the length of each grid. Okay, now come back to the picture. So, what is the period? Where is the period? How long is the period of the blue curve now? 1, 2, 3, 4, 5, 6. So the period of the blue curve is 6 times larger than this number. So this is 6 times pi over 24. This is the period of the blue curve, which is equal to what? Pi over 4. Yes? This is the period of the blue curve. But the book has mentioned that the blue curve is this. We know the period of the blue curve should follow this rule as well. So it is 2 pi over b. On the one hand, the period of the blue curve should be this. On the other hand, using the information on the graph, I found this pi over 4. So these two should match. Yes? And this will give me the exact value for b. What is the exact value for b? I multiply, it is pi, b is equal to 8 pi, and then pi and pi are simplified, so b is 8. Yes, so this means that from the graph we immediately read a, which was 1, and then by calculation, a little bit indirect calculation, I realized b is 8. So that will be the graph of the blue one. So I would say this is a really good question, even though they consider level 2 problem. Yes, it is level 2, but it's a good question. Let us go back here. Do you have any questions regarding this? Understandable? Yes?
Instead of calculating all the
Great.
all the grids, yeah, couldn't you just say that it's 4 of these periods and then divide it by, instead of doing
Yeah, that's also
6
good.
over 24?
Yeah, that's also good. So what you are saying, you are suggesting that this is half a period.
Yeah.
It contains 2 full periods of that. That's also, yeah, that's up to you. But I want you to understand how you go back and forth between the information. What Abdullah mentioned is also good. By the way, let us do that, okay? So Abdullah mentioned that instead of doing this complicated way, if you are good in solving equation, you just put this equal to 0. And then you find the zeros. Let us just do that, by the way. It's a good idea. So it means that I will take 1 over 2 cosine 2x and put it equal to 0. I multiply everything by 2, so it becomes cosine 2x is 0. And then where is cosine 2x is 0? Pardon? 1/3. Thank you. But then you multiply by 3, you will get this one. But cosine is supposed to be 0. Where cosine is 0, either you are here or there. Yes? But do you remember, so you can write 2x is equal to 90 degrees or pi. Yes? If you write plus 360 degrees, that is okay. Then you have to write another formula for the negative one. But instead of writing 360 degrees, one for this, one for this, I hope that you learn this trick now. You just go 180 degrees. So this is better to write this as n pi. Yes? Why did I write pi? So that was my mistake. This is pi over 2, sorry. This point is pi over 2. Understandable? And then you divide by 2, x becomes pi over 4 plus n pi over 2. Of course, you shouldn't expect to get one answer. You get infinitely many answers. But you need to find the minimum positive one, for example. You need to find one of them. For example, what is the minimum positive one? It's pi over 4. Because if I put n equal to 0, I get x equals to pi over 4. If I put n equals to minus 1, this becomes minus pi over 2, pi over 4. I go to negative part. Okay? So this is the smallest positive. This is important, by the way. If you just put 1, you get another one. Okay? You need to know which one is that. You need to find, for example, the smallest positive one. The smallest positive one is pi over 4. Okay? And then you go back to the picture. So what is happening here? This is the smallest positive value here. You see, this red curve has this. This is the smallest positive root of the red curve. And we calculate it to be pi over 4. So each grid is pi over 4 divided by 6, which is pi over 24. So that's also one way. Sometimes this is easier, because this definitely will answer. Here you have to do some gymnastics, going back and forth. But here you just do the calculation, yes? So that is also valuable. This is why I brought this up. So is that understandable? But of course, if the graph is a little bit complicated, solving the trigonometric equations are also somehow complicated. But if you're okay with that, that's understandable. And most of these questions are the type of questions that actually only the final answer is required. Okay, so that's, you need to convince yourself somehow. Okay, any questions? Okay, so the next part of the lesson will be, of course, a little bit harder, and then 2 more things will be left, and this long chapter will be finally finished. Yes, and then you will be ready for the exam, hopefully. Okay, no questions. Thank you.